11.2 Areas of circles and sectors. Essential question. How can you find the area of a sector of a circle? Let's take a look at finding the area of a circle. Remember that the formula for the circle is area is equal to pi r squared. Now that differs from the circumference formula, which was c is equal to 2 pi r or pi d. One of the characteristics is that the radius is squared, which creates the square units in the area answer. So we just go ahead and find the radius, 2, 4, 6. So that's 6 squared. And the exact answer is 36 pi, or you can put it in your calculator and find the decimal version. Now I'm going to go on to the next screen and show you how we find 1/4 of a circle. So to figure out 1/4 of a circle, you're just going to find the whole circle itself and just take 1/4 of it. And so you can see here how I go about doing that. Here's the exact answer, 9 pi, and then here's the approximate. We can do this with 7/8 and we can do this with 2/3. The method is very much the same. Take a look at this. All you do is find the area of the circle and just take the portion that you want, 7/8. And you're going to be working with fractions a little bit. And here's the answer, 11.0 square units. Here is 2/3. And here is the answer, the approximation. Okay, so the area of a circle. The area of a circle is pi r squared. We're going to take this circle and we're going to divide it into little wedges, or these are called really sectors, and then we're going to realign them so they look like this. It looks a lot like a parallelogram. Remember that the area of a rectangle is base times height, and the area of a parallelogram is also base times height. Since this looks like a parallelogram, I'm going to write the base, and the base is right here, and that's really half of the circle right here. Okay, and so that's going to be 2 pi r, which was going to be half, so we'll just do pi r. And then the height right here is the radius, and that's how we get pi r squared. That's why the area formula is that. All right, let's take a look at utilizing this formula in various problems. Here, it's always good to start off with a formula. Area equals pi r squared, and we're looking for the area, so we're going to put 2.5 in, and then use our calculator to find the decimal version. I'm going to go ahead to the next screen, and I'm going to show you how we do the next problem. They want us to find the diameter. We can't find the radius, so what I'm doing is I've been given the area answer, so I put the area answer right in here where it says area, and I divide both sides by pi. To get the radius, you're going to have to take the square root of that. We put that in our calculator, and I'm going to get a radius of about 6.0 centimeters. Now I'm being asked for the diameter, so don't forget, last step, to double your answer to get your diameter. All right, your turn. So go ahead and stop the screencast and then take a look at the answers. Here are the answers. Again, it's a good idea to go ahead and put down the formula, substitute everything you know, and then solve for what you don't know. We're going to take a look at population density. Population density is the number of people divided by the area of the land. And a lot of cities grow in a form of a circle. So studying circles right now, it'd be a good idea to take a look at population density. All right, so here we have a circle that represents the area of a city with a 5-mile radius. So I'll put 5 right here. And we know that this many people live in that entire city, and we'd like to figure out the number of people per square mile. So right here, how many people are living in each little square mile in this city? Well, again, write out the formula. Density equals number of people divided by the area. And in this case, it's an area of a circle. So we're going to be writing 430,000, and then we're going to write the area, which is pi, and in this case it's 5 squared. I'm going to go to the next slide to show you all the work I did. very similar to what I did here. Now, you have to be careful when you're entering in your calculator to make sure the calculator knows what the denominator is. So don't forget to put a parenthesis around the 25 pi. And here's the decimal version, and I always like a label for density, people per square mile. Now, the next problem, what's interesting about the next problem is that they're giving us the density. So again, writing out the formula is a good idea. Substitute what you know, and what we're looking for is the number of people. So I put P for people, and here's my area. And this looks a lot like a proportion, so I went ahead and put over 1, and I will cross multiply. And remember, this represents people per mile squared. This represents miles squared, so dimensional analysis will have the meters squared cancel, and we're only working with people, and you end up multiplying 6,195 times 9 pi. Okay, your turn. Go ahead and try the problem, stop the screencast, and look at your work. And here's the work. Again, start off with the formula, substitute everything you know, and solve for what you don't know. Area of a sector. Well, what is a sector? Well, a sector is a region bounded by 2 radii. So here's a radius and here's a radius, and by the circle. So this wedge right here is called a sector. Now, the area of a sector can be written in 2 ways. You can write it in a proportion method, or you can write it in a formula method that looks like this. So this portion of the area is to the whole circle, as the degrees in this arc is to the degrees in the whole circle. So if you like the proportional method, this is what you would use. Or what you could do is you could cross multiply here and take this and multiply it over here, and you'll get this formula type version. Area of the sector equals the fraction right here times the area of the circle. And if you notice, when we started the lesson, this is the way I did it. I knew the area of the whole circle, and I just figured out the fractional amount. That's what we did at the beginning. All right, let's take a look at this problem. I want to find the area of the sector formed by this angle. So there's 2 areas. There's a small sector and there's a large sector. So on the small sector, again, small sector, if we go back to what we were doing at the beginning, I just want 70 out of the 360 times pi r squared. So this is the fractional amount. How much of the circle do I want? And then times by the whole circle. Now the next slide will show you all my work. Notice that when I was starting to do the work, I actually simplified the fraction before I did the pi r squared. And for the large sector, I did the leftover from 360, which amounted to 29 over 36. Now, these 2 areas should add up to the area of the whole circle. And if you look, I did do that for you. I found the area of the whole circle, which is 201.1, and that's what these 2 add up to. So that makes sense. Okay, your turn. Go ahead and see if you can find the area of the red sector and of the blue sector. And here's the answer. Again, you can check your work by figuring out the area of the whole thing, and notice that these 2 do add up to it. Okay, I'd like to find the area of the circle, and I've been given the area of the sector and the measure, but I want the whole circle. So again, there are 2 formulas. You can either work with the ratio formula, which is area of the sector divided by area of the circle times the measure of the arc over 360, or you can work with area of the sector equals measure of the arc over 360 times area of the circle. And that's where we take this when we move it to the other side here, like that. All right, and so on the next slide, you'll see my work. And you can work it either both ways. 35 over the area of the circle. This is what we're looking for. We're looking for the area of the circle. And I went ahead and I reduced. And then I cross multiplied. And I got my answer. So that's one way you can do it. If you like this formula method, then instead of saying pi r squared, just say area of the circle, because that's what it is. And again, here's my fraction, like I had over here, 1/9, and I multiply both sides by 9, and I get the same answer. Okay, here is a problem where they want you to find the area of this painted region right here. And you can see that you don't want to paint the entryway, which looks like an archway here. So the area of the paint will be the area of the entire rectangle, this big rectangle, minus the area of this little rectangle, which ends up being a square really, and 1/2 of the area of the circle, because this arch is half of a circle. So you can see I put in all my numbers for the big rectangle. Here's my square, and here's half of my circle, and I go ahead and use my calculator, and I get about that. Okay, your turn to find these problems. Stop the screencast and try your hand at it. Here are the answers, and this is the end of the screencast.